afternoon, everybody. My name is Gionas. I'm a board member of HETiA, and I welcome you to the Critical Infrastructure Management panel, which we have the honor of hosting four international experts, let's say, in this area. And let me briefly introduce to you. We have over the air, over the internet, Mr. Alex, Dr. Alex Papalexopoulos. Is he here? Can you hear Alex?
I'm remote.
Hi. Okay. Thank you. Alex is the president and CEO of ECCO International. He has more than 25 years of experience in designing energy markets across 15 countries. And his work has influenced policy regulators and industries worldwide. Next, joining us is Fotis Karonis, Executive Vice President for Connectivity, 5G and Edge at Capgemmini. Fotis has been instrumental in deploying 4G and 5G networks, and actually he deployed the first 5G network in UK. Is this correct?
I would say yes. Yeah.
Great. We are also pleased to welcome MikkoYlä-Kauttu. Hope I pronounce it the right way. Okay. Nokia's head of energy for mobile networks. He has more than 2 decades of experience in telecommunication global across Latin America, Europe, and Asia, and he deals mainly with 5G, IoT, and enterprise solutions for critical infrastructure. Last but not least, and I would like also to personally thank him for helping me, arranging this panel, Professor Alexios Birbas. He comes from the University of Patras. He has many years, I won't say how many years of experience. Okay, research microelectronics, IoT, and cyber physical system, and he has also driven innovation and created some startups in the past. Okay, let me start by asking our guests here to give us an initial, positioning about what critical infrastructure is according to their line of expertise and how they see things, and then we will come, to the question part. Let's take 3 or 4 minutes each. Let's start with Professor, and we go on. Thank you very much.
Thank you, Giannis. Thank you for the invitation. Good afternoon to everybody. Let me try to give a first definition of what critical infrastructure stands for. Critical infrastructure refers to the systems, to the facilities and assets which are vital for the function of the society and the economy. That's the basic idea. I can name a few, indicatively, a few critical infrastructures. For example, first of all, energy sector. That includes electricity grids, includes oil and natural gas pipelines, includes also nuclear reactors if they are existing. The second one is the chemical sector, for example, which is it's a critical infrastructure which comprises refineries, oil and petroleum pumps, all these kind of things. Another very important critical infrastructure is the transportation sector, which includes airports, seaports, highway roads, bridges, whatever it is for the transportation system. Even the public transportation systems belong to the critical infrastructure of transportation. Another one, which is very also important critical infrastructure for everyday life, is water and wastewater facilities. Another one is the financial sector, for example, stock exchanges, clearing systems, payment systems, etc. Also, the healthcare, which includes hospital clinics and the medical technology supply chain, which is very important also. I would like to conclude this indicative, let's say, critical infrastructure sectors with 3 sectors, which I think is our main focus today. First of all, one of those is the emergency sector, critical emergency sectors, which includes the police, the fire departments, also the security departments of the government, all these kind of things, defense sometimes. And there are two other critical infrastructures, that of telecommunications, which is very important critical infrastructure, includes the communication networks, the wireless infrastructure, also the internet infrastructure. Also, I would like to mention that this communication infrastructure includes also the SATCOM, the satellites. This is an important sector as well. And the third one is the information technology, or what we call digital infrastructure, which includes the data centers, includes all the hardware, software installations all over the countries and all over the world, which are vital for the functioning of the society itself. All these infrastructures, these critical infrastructures are interconnected. Nowadays, they are interconnected between each other. What is important is that means that if we have a failure to one of critical infrastructure, this may have a cascading effect to the other critical infrastructure. This is very important. And the last thing which I would like to mention regarding the critical infrastructures is that themselves comprise a cyber-physical system. That means that it is prone to instabilities of the communication and the digital system itself. In that sense, that's maybe drive our today's discussion, is that the communication sector, the digital sector, are the underpinning critical infrastructures which enable the operation of all the other critical infrastructures.
Great. Thanks, Alexis. Let me come now to Alex, Dr. Papalexopoulos, to provide us his point of view. Say, he has a small presentation. I will be having the role of changing the.
Okay. All right. Thank you, Yanni. Can I see the presentation? Is it?
Can you? Yeah. We can see it. I don't know if you.
I cannot. Okay. Yes. I'm Alex Papalexopoulos. As John said, I'm the CEO and president of ECCO International. I want to thank the organizers for inviting me to speak today and share my experience with you on this important subject. I'm connecting from the very far away place of San Francisco, California. In our business, energy, due to climate change, there are so many events that are happening, extreme events with increasing frequency that really challenge the grid infrastructure that is so critical for the economy. Planning for those extreme events, in addition to planning for normal events, it's a very complicated challenge. The modeling and the analytics are very complicated. They have huge economic consequences. We're moving to a philosophy now where the major principle is resiliency and reliability at a price. We cannot really ensure 100% reliability or resiliency of the power grid infrastructure. An important aspect of this evolution is the digitalization of the power grid. This is very important. There are now sensors that are popping up all over the place that they measure various things throughout the grid. So we're talking about millions of sensors. And these technologies have allowed what we call the decentralization of the energy system, of the power grid. And this is very important because they enable the customer to be part of the critical power infrastructure. In essence, now we need to respond to milliseconds by utilizing the information from hundreds of thousands or millions of sensors with software in the cloud. And this allows us to develop new markets, new products and services to manage the power grid infrastructure. And for that, the 5G technologies are very critical. Next slide, please. Basically, we have two major global market forces. On the right, we have the consumer electronics revolution. On the left, we have the need for the decarbonization of the system, of the energy system, as a result of the climate change. In the middle of those two global major market forces, we have the power grids that, as I said, because of digitalization, they are moving to a decentralized state with the millions of IoT devices that are connected everywhere in the system. All the technologies are moving to the cloud. So we'll have new technologies now with distributed control, ML, and artificial intelligence. And it's the key factor for the evolution of the markets. And I'll talk about this in a second. Next slide, please. In essence, we have the energy cloud. Everything is measured from devices that we had in the past to new devices in our business, like EVs, storage, electric storage, renewable energy. We pull this data to the cloud on a second-by-second basis, or millisecond-by-millisecond basis. We segment load in different categories based on how flexible they are. And the software in the cloud provides, based on predictive analytics, the status of the grid. Based on that, we attempt to improve the grid by utilizing generation and load assets. Next slide, please. So what we have what we call the emergence of hierarchical energy market structures. On the top, in the middle here, we see market operators and transmission system operators. These are wholesale operators like the power exchange in Greece and like ADMIA in Greece. But below that, we have the emergence of local markets. We call those distribution system operator markets, and LEM, local energy markets, operating in a neighborhood level, small town level, or smart city level. And below that, we have the customers that through aggregators, we call those DR aggregators, that stands for distributed energy resources. They participate in those markets. So we have the evolution of what we call the TE business model, the transactive energy model, which is basically peer-to-peer, business-to-business, bilateral deals in energy. And this decentralization has helped improve the resiliency, but still the challenges are very, very complicated and difficult to solve. So it's a work in progress. Next slide, please. A lot of work here, a lot of work under the hood, a lot of work in analytics. On the left side, you see in a level of buildings, assets that we measure, and we control and monitor. We aggregate. The aggregation takes the form of different colors in terms of flexibility. We create aggregations. You see the aggregator company, these are mid-level companies on the lower right, that they produce curves that they are submitted to wholesale markets. And this model is allowed because of the technology improvements, and now the need for 5G technologies to make this happen and develop new energy products that operate on a second-by-second basis or on a millisecond-by-millisecond basis are so critical to improve the resiliency of the power grid critical infrastructure. Next slide, please. Okay, now the grid, the power grid infrastructure, it has what economists call characteristics of public goods. So resiliency has characteristics of public goods. If I improve the grid in one area, it also helps another area. that requires some form of intervention from governments and regulators. It requires some private-public partnerships and some form of planning. There is a role for the markets in terms of bidding to provide equipment and services, and moving to what we call performance-based rulemaking for infrastructure owners. Now, a key thing in our business is investment auctions now that have a very long time horizon, let's say 10 years or 20 years, for resources and transmission auctions to improve the grid with clean energy constraints. However, the challenge we have is how those investment auctions align with the short-term spot markets we have currently to produce market signals. There's also problems with the counterparty risk, because we have what we call very fat tails at global micro correlations for these extreme events that we need to model and manage. And of course, now we start moving to an AI-based super planning model to be able to deal with the power grid critical infrastructure. I have one last slide. I close with this, that given the decentralization that we're experiencing, I forecast that basically the new electric company is your home. This is very important. This level of decentralization will help the power grid infrastructure, will help deal with extreme events, will help small networks in a level of a city, smart city, or a smart neighborhood, disconnect from the central system to protect critical facilities. And the ultimate of that in terms of granularity is your home. Of course, grid investments are required, but it's very important to allow the development of new markets, new products, and new services that will allow the full decentralization of the grid infrastructure. Thank you.
Thank you, Alex. Let me move now to Fotis. Thank you.
I have time for slides, but what I have to say
please,
first of all, I'm super excited to be back in Greece and moving after 15 years living in London.
Yeah.
So this is an incredible moment. Thanks for the opportunity to speak here today. I've been in the industry of telco and then in CTIO roles in British Telecom, EE, etc. And it's a fantastic timing to be back in Greece, and hopefully I can help. So I'm still working for Capgemmini until the end of the year, it's great to be seeing of what do we do with these 5G networks. That's the great opportunity. Building networks is one thing for consumers, and working in the broader ecosystem in large scale deployments and operations. But it's important to give back to the society. What are we going to do with these? How does these networks help providing value and providing that back into the society? And I think the critical infrastructure topic is very important, because that's where we really see a great value and a return to our society with the transformation of these industries. I would say these are the main industries that I see a strong contribution for digital transformation. One is public safety. We know that the crises are becoming more intense, more frequent, and requiring many bodies to work together in a coordinated manner. Critical national infrastructures are also, of course, we mentioned, Alexis, you mentioned about the electricity, and Alex. It's also healthcare, it's railway, aviation, etc. Chemicals, logistics. I mean, what is not critical? Even the automotive, right? Because if you have a problem, and it is a critical infrastructure. And then, of course, the new sectors that are embracing, I would say, also the 5G connectivity and advanced connectivity is defense. I mean, this is super important now for inter-domain communications. NATO has embraced the usage of 5G, even for tactical bubbles and more, and also in logistics and security. So that is a very important sector as well. And then last but not least, satellite, and which you mentioned as well. Satellite aerospace is vital because also the 3GPP standards have been embraced there for, you know, payloads and all that communication between ground and air. So yeah, I mean, this is an essential, I would say now, horizontal opportunity. Have a better society, saving people's lives, and tackling some of the undesired situations of today, which are the threats of course, cybersecurity, but also the crises from extensive and you know, environmental issues, etc., where you require video, you're required to actually see what you're going to tackle and then cooperate between them. Technologies that are used today that are struggling for this new future, for this new situation, analog technologies, but also the tetra technologies, which is fantastic. It's very secure and it's got security, but it's not, it's limited to voice. And when we're talking about crisis management, we need a combination of, you know, voice, push to talk, where wider groups can talk together, but also video and seeing what is going on, talking with a NOC, with a network operating center or a crisis management center, and ensuring that the police, the fire brigade, and you know, the healthcare services, but also the military are collaborating in order to resolve an issue. I think the industries as well, which I'm sure we will have the chance to say a few words, but they are critical and they require, you know, usage of secure networks. 5G plays a very important role, as like in nuclear, in railway, etc. We're seeing more and more these use cases, and I'm seeing that in the larger projects, which is also a way of course, providing added value services, but monetizing also these huge investments, these public investments, or the telco investments that have been done. It's an opportunity to see, you know, what we can actually do to provide, you know, new solutions and services. I will also have the chance to speak about some of my experiences.
And I would say, Mikko, that this is also kind of a new industry coming up, isn't it? I mean, the combination of telco and critical infrastructure and all these kind of things, isn't it?
Yes. Also, good afternoon from my side as well. Happy to be here. Thanks for invitation. My colleagues here already explained.
We have some time more, don't you? I guess it's we have another 20 minutes. Correct. Okay. Thank you.
So my colleagues already kind of explained quite a lot of, you know, the reasons why we need this critical infrastructure network. So thank you for that. And then that's why I think I'm gonna go directly on looking at here why you need that and what kind of things you need to do there. And thanks for mentioning this tactical 5G in defense. We just launched our latest version of that today, so good timing. I would like to address first, you know, the kind of modernizing the public safety networks. Why is it crucial? I mean, like Fotis said, you know, there are kind of old, kind of legacy networks there, which really need, you know, modernization. And why it's needed? It's because the reliable connectivity you need in order to really do it more efficiently, the limited capabilities of the old technology, because they've been built some maybe 20 years, 25 years back. I think you were involved in one of the first tetra in the country.
Yeah,
so,
like
yeah. And then, of course, I mean, a technological advance, you know, you can do so many more things with 4G and 5G, you know, the video, the voice, and also kind of a low latency communication, and everything that you need, for example, in a mission critical.
Later, I will ask you how secure this is. I mean, I've been working in Ericsson for many years. I know it is secure, but we need also to convey this message. But later on, we'll discuss about and how this is compared to Tetra, for example.
Exactly. I mean, even in 5G, you have more advanced, every generation, you have more advanced security algorithm there that helps you to protect that. Then, if you look at, you know, kind of energy utilities, these are also part of national critical infrastructure, just like said, you know, and they need this private wireless for the resiliency, which is important for actually all the critical infrastructure, reliability, low latency, data control, again, security. And then you need to be able to customize and have the flexibility based on, you know, when the kind of new renewable energy resources are moving, or think about electric vehicle when they are moving. You know, the electric network needs to be so much more flexible compared to what they're today, and the scale and the IoT and device, you know, density. The price of the devices and the sensors are going down all the time. So now it's not anymore so much cost. You can put it all the different places so you can get all the data, but you need to be able to have a network to really manage that, even though it's one sensor sends very little, but there's still a lot of data there. What are the kind of benefit of that? That's going back to the sensors and all the other capabilities. You have the kind of remote monitoring, incident management, the cyber security and network security enhancement, i.e. utilizing, for example, AI to understand if there's anomalies in network and take actions based on that, there's a threat, possible threat there. Then worker safety and wearable technologies that helps, all this kind of work, bringing in augmented reality, virtual reality to help, bring additional expertise to the field force or something like that. And then drone and robotic spectrums. A lot of money to be saved there that when you can utilize the drones to inspect, for example, wind parks or power lines. One more thing that I want to address is then also that together we can partner on this and make sure we build a robust wireless infrastructure. We have in Nokia full end-to-end solution to build all what is needed, starting from the radio score, all the services, network management, security, and also this interworking, that's key. So you want to build something based on 3GPP standards so that you will actually have ecosystem. So you have all different kind of devices and different kind of price points, different kind of usage. And then also, since it's utilized all over the world, then you also have a better price points. And there's a kind of sustainable future in that perspective that they will be maintained because all the others are using that as well.
Network economies, isn't it?
Yes, yes. And also there's a kind of future development on that.
Yeah.
One more thing, we really consider public safety, defense, and utility very important from our perspective in Nokia. And we do some specific development for those, taking care what are the specific requirements for different sectors, because that's kind of a key. It's not just, the basic network you can build for the operators. Yes, we use the same technology, but there are some specific requirements. So that's what we do, and then we work together with also a little bit regulators, because regulators are the ones who are enabling that the frequencies are there, that these things can happen, and kind of a legislation supports, and we advocate them to be supportive and enabling this kind of development in every country. Thank you.
Thank you, Mikko. Let me come now to Professor Birbas and ask him, do you see any threats in critical infrastructure, and also what is your opinion on how these critical infrastructures could be managed effectively? I mean, what is your opinion on this?
Yeah, critical infrastructure faces various threats, to my opinion, and these threats can disrupt its operations and pose threats also to the economy as a whole, and also to the society and well-living in society. The common threats which I can say is that there are cyber threats, for sure. There are physical threats. There are natural disasters, as both you, Alex, and you, Mikko, mentioned before. There are pandemics and health emergencies, which is also a very big threat in our days. We have experienced recently that threats. Also, supply chain vulnerabilities, which can be also a very big threat to the critical infrastructure systems. We also experienced this after the pandemic recently. And also, there are technology dependencies, because all this critical infrastructure depends strongly on various technologies which are not always available in the supply chain. This is more or less the threats which the critical infrastructure face today, to my opinion. And now, if you ask me how we manage to overcome those threats, and how we'll mitigate these threats in the critical infrastructure, so that can be efficiently managed, ensuring the reliability, the security, and the resilience of the critical infrastructure. This, in my opinion, is definitely has to be based on the new and emerging technologies, networking technologies and communication technologies, 5G and beyond. That is the main reason for that. But I would like to stress also that this deployment of the 5G networking infrastructure enables also the efficient deployment of software infrastructure, which will control and maintain the cybersecurity, the critical infrastructure themselves. That means that we have to let's say, have robust software systems and hardware systems, which, as they are deployed all the way to the network, to the wireless network itself, can provide the control, the security, the maintenance, the preventive maintenance we need in order to have this, manage this critical infrastructure.
Thank you. Alex, what's your opinion on using 5G on power grids? I mean, do you think that this would help and make the system more reliable, resilient?
Yes, Yanni. As I mentioned, the key important development in our business is natural disasters resulting from climate change. They come at an increased frequency now. This has a big impact on the security and the resilience of the system. So the key evolution in our system is the granularity of the microclimates now in a local level, which requires response, prediction and response in a very, very granular level. And also the time component, we need to respond to events in milliseconds. Given the explosion of data resulting from millions of sensors now that are in the system, we require 5G in order to be able to respond to natural disasters, and also, importantly, engage the customer side of the equation. All our work for 30 years was really based on how the generation side responds, but we didn't have the technologies, the data to incorporate the customer. So the smart grid development allows now to have 5G technologies to respond to natural disasters much faster. This is very important. Furthermore, 5G allows the development of new markets, new products, and new services that work on a millisecond basis. For example, there are functions that have to do with the frequency of the system, and we require now market products to respond in millisecond level. Let's say there's a product called fast frequency response to arrest frequency deviations if there is a major outage in an area. And for that to happen, we need new products now. All our markets so far work on a 5-minute basis, but now we need to move to a second-by-second basis and millisecond by millisecond basis. And the only way from a communications perspective, infrastructure perspective, is to deploy 5G. And we have done so, and we'll keep doing that more and more. And again, why we need to do this is the explosion of sensors and the data we collect from customer sites that we didn't have before, not only for new assets that are all connected now, not so much on the transmission system, but all the way down close to the customer in distribution level, from EVs, electric batteries, rooftop solar, other type of renewable energy, monitor, control, and financially settle all those assets in that level requires new products, new markets, new services that operate on a second or millisecond basis in a much small granular level. And for that to happen, we require 5G. And that's why 5G is entering our business. Thank you.
Thank you. So, Foti, what do you think, from your point of view, are the advantages of using 5G technology? And do you see any building blocks they are applying the architecture?
Sure, thank you. If I take it from first of all, as a system, as an ecosystem, I can break it down into the wider families, let's say. First of all, in big projects like public safety or mission critical, large scale national infrastructures, you do require a reliable mobile network, LTE and then 5G. In order to do that, it has to be beyond the capacity and the spectrum that you need to have, a large amount of spectrum so that you can cater for the consumers, the industries, but also the mission critical part of the agenda, which can also be enabled by standalone 5G because of the slicing, etc., in the later stages. But at first, it's the coverage and the reliability, because if you have a situation of, as Alex mentioned about, environment, huge environment problem, that breaks down your network. It happened in parts of Germany when there was these big, water problems of rivers. And so you need resilience of the network itself, the radio network. You need, of course, resilience of your core. You need a distributed core. But on the radio, I'm talking from experience because I did the emergency services network in the UK based on the EEBT network. We had to work for about 3 or 4 years to harden the network. So we need coverage of high coverage, 99% geography, Every road has to have, full coverage. When you're riding 100 miles an hour on the highway, you need to have full connectivity as you actually roam from one side to the other. You need to harden the network in terms of the singleton sites have to have, sort of a backhaul, satellite backhaul, so that when you lose your prime connectivity, you have a satellite backhaul. You need to put energy so that you have, capabilities to maintain that energy. So a telco operator to take the responsibility to make the public network resilient and fault tolerant, it's a responsibility. You have to invest in that, okay? So that's number one. If I take the core, I think we mentioned we need a distributed core so that it can take the loads in different areas, and also the latency, because the core, the more distributed your core is, the more closer to where things happen, the smaller, of course, the latency is. And the other big component is the MCX, the mission critical server, if I may call it, or software, which replaces I would call it the core, I would say, tetra function that we used to have. And that there are several very reliable companies that provide that worldwide. I can give you an example in France where I worked maybe in the second question. Or in the so that's a very big important component. And of course we talked about the devices and I think it's important to think that if it's a pan-European, which is a pan-European initiative under BroadNet now under the European Union, so that all the countries can move into using FCX and broadband, provided of course the technology is sound and reliable. The devices, like, starting from the chips, because that's where we start. So if you look at the Android ecosystem, it's mainly, Qualcomm, for example. Do they have all the carriers? Can we put in the 450 megahertz, which is very widely used in the utility sectors? I think these are questions that we have to push the industry so that we can have a broader and lower cost operation and maintainable operation. One of the problems today with Tetra is it's not taught in university anymore. Yeah. There's people that were in these industries have moved into the mobile industry, into the 3GPP and stuff. Yeah. So we're running out of steam in Europe and beyond, and that's where we have a multitude of digital transformation programs that enable these systems to come into play with MCX, etc.
Thanks. Mikko, what's your experience using 5G in critical infrastructure? Do you have any case studies, any examples in mind you could share with us?
Yes. I think we have quite many. Fotis mentioned already public safety. One of the most interesting maybe example comes from Belgium, where we have built a countrywide 5G drone network for the public and safety. So you can have the eyes on the sky even before the first responders leaving from the station. So that gives you kind of an excellent example, what you can do, And then there are several different examples, different parts of the world, especially a lot of those in the US where they have drones with the first responders. So maybe not the whole country network, but when first units arrives there, then they put the drone on, and then immediately you have a situational awareness of 360. Or then if you look at a couple energy utilities, I mean, we have a little bit north from here, 450 Connect in Germany, who are building countrywide 450 megahertz network for all the utilities. Similar way, ESB in Ireland is building kind of also a network there for the grid management and smart meter deployments. And the first industry private 5G for utilities was just announced a couple of weeks back. We are building with Southern California Edison in US a network which are utilizing to build a really secure high capacity network, and that helps their acceleration on the path to carbon zero. So I think there's kind of a lot of these kind of things which are moving, and you know, having this happening several different countries with several different players also creates the ecosystem that Fotis mentioned, which is key. And all of these, our customers, they're also kind of looking at, hey, do you have ecosystem? Do you have a different kind of devices, ruggedized phone, iPads, you know, the different kind of sensors? I mean, one of the key use cases in US is the fallen conductor. So you need to have the 5G, you need to have the latency that electricity is cut before the wire hits the ground. So you don't do the, you know, you don't cause a forest fire. So, you know, something very simple as that. But in US, you know, if you go to the court and you cause that, that costs much more than private wireless network.
Yeah.
So there are many of these, and I think, you know, all this kind of distributed energy resource and balancing supply and demand, I think that was extensively already explained. And those are kind of main reason why energy utilities are thinking of private wireless. And private wireless is the only way that you can actually have this resiliency and security there. Because operator might have 1-2 hour battery backup time, and then that's not enough for the utilities. Utilities want a day or 2 or 3, so that there's enough battery backup so the network works when you don't have energy, so you have enough time to restore the energy.
Correct. And starting my short last round of 1 minute each answer question, starting with you again, what would you be your 5-cent tip, let's say? I mean, what would you suggest, you know, going further? What should we do as Europe, as Greece?
Well, as Europe, there's already kind of a good initiative from EU Radio Commission recommending that 450 megahertz would be prioritized for utilities. So 410, 450 are kind of the most common ones, depending which country, but you know, same base station can handle that, and also same devices. And that's kind of important part, that it gets similar way as other frequencies gets kind of prioritized and standardized for certain use, so they have the ecosystem. And that's kind of lowest to get the best possible coverage. And that's the same thing here, looking at, hey, what does it require increase to further develop that and, you know, modernize the network? There are going to be so many other countries doing the same. So it's kind of a good timing to be on the board there.
Great, thanks. Fotis?
Thanks.
Yeah, I think we need to really be based on best practices. You know,
Yeah.
I look at, you know, starting from, well, Greece, for example, the example of what the project I'm working on in France, which is a huge project for the Ministry of Interior of France, where we are, where the network is provided by Orange and Bouygues Telecom. So there's an infrastructure with national roaming to enable the public safety. So this is for 400,000 users, right? The police, the fire brigade, the SAMU, the medical services, and even the army is joining, right? So we did tests during the Olympic Games. It's a contract that Airbus Defence with Capgemmini, we are doing the program management of the whole thing, I think the model that is being put in place in France is that there is an agency which brings together a thin agency of just 50 people actually, called ACMOS, which enables to actually operate an MVNO service for public safety, for mission critical. It starts with the 3 police, fire brigade, and healthcare services. It extends to the army for internal usage, but also the critical infrastructure like SNCF, RATP, the nuclear power stations, etc., the EDF. These will slowly connect to this so-called RRF, which is the radio network of the future, Réseau Radio du Futur. This model is, I think, an exemplary model for Europe. And I think that if we don't want to reinvent wheels, I think it's good to use some best practices in Greece too, because the crises are becoming more intense. They're becoming much more frequent. We don't win silo organizations. We need the police to talk with the fire brigade. We need to have video, AR, VR you mentioned. We need to have reconnaissance of what are we going to tackle. And today we are slightly, I think siloed. And I think that's an opportunity, I wouldn't say to leapfrog, but to really be state of the art.
Yeah. Okay, thanks. Alex, okay, can you give us, your final, idea of how energy markets could support grid resilience according to your point of view?
Okay, thank you, Gianni. In summary, we view power grid resiliency in terms of three major factors now. One is the grid itself. Second, the generation sector. And third, the customer, the engagement from the customer. In terms of the transmission, the grid itself, markets over the last 25 years that we have been developing those markets have not performed very well. In other words, they cannot give us the right price signal for the expansion of the grid itself. For that, we require government support, and we require regulators to set up some standards. So we're talking about public-private partnerships. However, the energy markets, given the massive penetration of new assets close to the customer in the distribution grid, that's where most of the investments take place today, have helped improve the resiliency because we're developing now new markets in a local level close to the customer, new products and services close to the customer. That's very important for the resiliency of the grid. So all three factors have to come into place in the planning process, meaning generation, transmission, and load, to determine what's the best way to solve a specific problem. Transmission expansion grid expansion is very important, but we need to make sure as the system moves towards decentralization, we don't want to have what we call sunk costs and assets are not utilized. Don't take me wrong, we need the grid more than ever. We need to improve the grid, and since we are, this forum is taking place in Greece, Greece needs better interconnections with the neighbors. Europe needs better interconnections for cross-border trading. If you have a transaction between Germany and Austria, 35% of the transaction goes through Poland. It destabilizes the grid in Poland. So the way the system works now, for example, as a result of the war in Ukraine, all the power goes to Ukraine through the Balkans, through Greece. And as a result, our prices in the market are higher and higher and higher. So economics are very important. To improve the grid infrastructure and the resiliency, we need to take into account all these components: the generation sector, the load, the customer engagement, and the grid itself.
Thank you, Alex. Sorry, we're just pressed by time. Alex, give us a few things, a few ideas about the interdependencies that you were talking earlier, and we can close with that.
Okay, I will be very, very short on that. Let's take by example. Let's take three critical infrastructures: the communication infrastructure, as we mentioned before, which is 5G and beyond technologies, the computing infrastructure, the digital infrastructure, and the energy infrastructure, to make an example. How can have detected interdependencies between the communication infrastructure and computing infrastructure? Communication infrastructure, 5G infrastructures itself can help expand what we call a computing continuum. That means that enables the computing continuum to spread from the cloud to the edge. This is very important, and also this kind of connectivity is inherent in 5G systems. That means we have a more efficient computing resources, and we consume less power for computing because we move things wherever we need to move things, computationally wise. That's the first thing. The second thing is that if we have this kind of infrastructure, because 5G operation and networks orchestrate the computing environment, suppose we have such a system and we have a power system, and we have a power outages somewhere, close to the cloud, close to the data center. Because of the nature of this cloud edge computing continuum, we can isolate things to the edge and have the edge operating. For example, if this is a substation, for example, can have the substation operating with a local computing resources without referring back to the cloud. This increases definitely the resilience for the three of the critical infrastructures.
Thank you very much. Thank you, all of you. We are 4 minutes late, but it's okay. I think it was interesting. Thank you very much.